the first thing we need to do is talk about the second fundamental theorem of calculus. All right, it's not too hard at all, but we have to go over some things on it. So on a second fundamental theorem of calculus, if I have this function, the integral from 0 to x of f of t, if I take a second fundamental, I'm taking a derivative of an integral. So when I take a derivative of an integral, if I go from a number to a variable, I just substitute in my variable and remember the chain rule. So g prime would equal f of x. All right. And so if I have another one, if I have this integral from 3 to x squared of sine x dx, if I call that g of x, and I wanted to find g prime of x, I would substitute in x squared, but I'd have to remember the chain rule. So when I substitute in, I'd get sine of x squared, but what is the derivative of x squared? 2x. So the 2x pops out. Now, I want to prove this one with you right here. So what is the antiderivative of sine x? Negative cosine x. So my first fundamental, I'd say, is negative cosine x. And I'd go from 3 to x squared, right? Well, if I substitute in x squared, I'd end up with negative cosine of x squared. And then minus, I'd substitute in now what? 3, right? So then I'd have cosine of 3. Well, if I subtract a negative, it doesn't really matter. I'd get that. So that is what g of x would be. Does everybody agree with how I did that for first fundamental? Are we good? Now, if I take a derivative of that, if I take a derivative here, what is the derivative of negative cosine? Negative cosine, the derivative would just be sine. So now I'd have sine of x squared, but what do I always need to remember? Chain rule. So what pops out? A 2x. Well, what's the derivative of cosine 3? Cosine 3 is just a what? A constant, so it goes away. Now, the second fundamental theorem is extremely important because when I take a derivative of an integral, sometimes this function is not antidifferentiable. All right? Sometimes we can't actually go backwards using the first fundamental. So that's why we use the second fundamental. All right? Taking a second fundamental is taking a derivative of a integral. And it has to go from a what? A number to a variable. All right? Except when it's not. So this is the extended version of it. So in this one, I have the integral from x squared to 3x of f of t. So if I'm deriving this, I can just substitute in the top one and just minus substituting in the bottom one. All right? And so I can kind of take away because of the constant. I don't have a constant here. This isn't used very often, but in case it is. So I now have f of what? 3x, but what pops out? A 3. Minus, now I substitute in what? X squared. So now I'd have f of x squared, but what pops out? A 2x. So that would be my derivative of that integral. See how that worked? All right, let's look at this next one. Now I have the integral from 5x to 3x squared. Again, I'm going from a variable to a variable, so I need to kind of mix the first and the second fundamentals. So I have square root 1 plus t cubed. This is honestly not even antidifferentiable. I can't take an antiderivative of it, and that's why this second fundamental is so important. So I'm going to substitute in 3x squared. So now I'd end up with g prime equaling square root of 1 plus what? When I substitute in 3x squared, what do I get? Substitute in 3x squared in for t right there. What is 3 cubed? 27. And then x squared cubed is actually what? X to the 6th. But what pops out by the chain rule? What is the derivative of 3x squared? 6x. All right, so I have a 6x going right there. All right, and then let's do the 5x. So now minus, now I'm going to substitute in 5x. So now I have 1 plus What is my, when I substitute in 5, what's 5 cubed? 125, and then I have x cubed. But what pops out by the chain rule? A 5. All right, and so that is kind of the extended version of the second fundamental. Normally it needs to go from a constant to a variable. However, they could do this from a variable to a variable. Rarely do they do it, but they could. Here we go. Let's get to the nitty-gritty. And this is why we have it downloaded on our iPad. All right, so now I have my function g of x is my integral from what? Negative 2 to x. So my starting position is going to be at negative 2. And so this is kind of where I'm starting, right there. I'm starting right there. And then I'm going to whatever x value it is. So if I find g of 0, that's basically saying the integral from what? Negative 2 to 0 of this function that's given to me. So if I'm going from negative 2 to 0, it would be this area and this area. Well, the area before right here is negative, and then this is positive because I'm going to the right. It matches up fine. And so what happens to those areas? They go what? They cancel out. So what do I get?
0.
I get 0. All right. Now let's look at this next one. I do g of 2. So now this would be the integral from negative 2 to 2. So then I need to go all the way over here. All right. And so this portion canceled out, right? So I don't have to worry about this anymore. So now I need the area of these. So what is the area over here? 1, 2, 3. So this area is 3. So g of 2 is equal to 3. See how we did that? Okay, it's just the area under the curve. All right. All right, let's do the next one. So g of negative 3. Which way am I moving now? I'm moving to the left. I'm moving backwards. All right. And so when I'm moving backwards, the area is opposite of what it normally is. So this is the integral from negative 2 to negative 3. I'm moving backwards. So what do I get here? What is the area of this? It's negative 3 halves, but I'm moving backwards. So what is it now? It's 3 halves. Now, some people don't like going backwards. So what could you do to these limits? You could flip them, right? So if you go from negative 3 to negative 2, however, what do you need though? A negative. If I do that, I'd have a negative area. However, it's a negative area, which makes it a positive. All right. Now, most of the time, I will just go backwards. I want you to just flip whatever it would be. If it's below the x-axis, it's now positive if I'm going backwards. All right. If it's above, it's now what? Negative if I'm going backwards. All right. Let's look at this next one. I now have what? G prime of negative 2. And so this is where our second fundamental of calculus goes into play. So if my g of x is equal to this, g prime would equal what? W of x. Okay, I'm going from a constant to a variable. I'm taking a derivative of an integral. So if I'm finding g prime of negative 2, that's actually just the what? The value right there. Because this is a what graph? A W graph. And a W graph is really a g prime. All right. And so, what is g prime of negative 2? Negative 1. All right, it's just negative 1. All right, let's do another one. So now we're finding g prime of 2. Well, g prime of 2 is talking about just the value of w at 2. Because g prime is equal to w of x. You see how we're doing? All right. So what's g prime of 2? It's just 1. All right. All right, let's do the next one. So now it's talking about what? G double prime. And so g double prime of x would equal what? W prime of x. And so this is a W graph. So what is W prime? The slope of it. So this is basically finding the slope of W at 2. And so what is the slope of W at 2? -1. So G double prime of 2 is -1. See how we put that together? All right, let's keep. All right, so now I have this one. So now I have G of x is equal to the integral from -1 to x. So where is my starting point here? Where am I starting this integral? -1. So I'm kind of starting right here. And what's left is what is right is going forward. What's left is going backwards. All right. So I now need to complete my table. So if I complete my table at -3, it's finding the area from -1 to -3. Well, what happened again? It went backwards. True that. They canceled out. So what's G of -3? It's 0. All right. Now, if I go to G of -2, then it's just finding the area from -1 to -2. However, we are going backwards. So what do I want to think of this area as? It's positive now. So it would be positive how much? It's not 1/2. It's 1. All right. How do we find an area of a triangle? 1/2 base times height, right? So my base is 1, my height is -2 kind of thing. And so it would be 1. All right. So now let's do it at -1. So what's the integral from -1 to -1? 0. Now we're going to 0. So which way am I moving now? I'm going forward. So now I'm talking about this area. So what is that area? It's -1. Why is it negative this time? Because I'm moving forward and it's what? Below the x-axis. All right, let's look at 1. So now I need to add this portion to it. So what would that be? Okay, that portion's -1/2. So now I need to add it to the -1. So then that would be what? -3/2. All right. And then I'm going all the way to 2. So what's the area from the integral from -1 to 2? -3. Exactly. All right. And then I need to go all the way to 3. So now I need to include this area right here. So how much is that now? -11/2. Exactly. All right, -5.5. -11/2. All right, let's look at part B. So what are the intervals on which G is increasing or decreasing? Well, what does it mean for G to increase? Let's go back to our last chapter, basically. What does it mean for G to increase? G prime is positive. All right, so I need to get to G prime. So what is G prime? Let's use the first or the second fundamental. What is G prime? F of x. All right, I used the second fundamental when I took a derivative of an integral, and the integral goes from a number to a variable. So I'm basically looking at this graph to figure out when what? When is G increasing? What interval is G increasing? -3 to -2. Because why? I can't say F prime here. It's just F is what? F is positive. F is greater than 0. Something like that would be great. All right. So when is G decreasing? -2 to 0 and 0 to 3. All right. Because why? F of x is less than 0. F is negative. All right? Because F is the same thing as what here? G prime. All right? And so I usually just call them all F prime graphs, but this is actually a G prime graph. All right. For what intervals is G concave up or concave down? What derivative do we kind of need to think about on this one? The second derivative. Well, G double prime is actually equal to what? F prime. Well, this is a what graph here? An F graph. Well, what's the relationship with F and F prime? It's the slope. So truly, I'm talking about the slopes of this graph. Do you see how we just thought about that? All right. All right. So when is G concave up? From negative 1 to 0. Love it. Because why?
Because the slope of f is positive.
Slope of f is positive. That's beautiful. That's beautiful. All right. That's a perfect answer. All right. And then when is G concave down?
Negative 3 to negative 1.
-3 to -1 and
0 to 3.
0 to 3. And then what is my justification part?
Because slope of f is negative.
Slope of f is negative. All right. You see how chapter 3 is kind of leading us into this? All right. They're kind of going to work together. All right. So on part D, I kind of want to change this up. I want to say for what point? I want to know the point when G has a relative maximum, because now we actually know the first fundamental for it. All right. So I want to know the point in which G has a relative max. Well, how do we get a relative max? G prime changes from what? Positive to negative. Well, what the heck is G prime here? F of x. So it's really when f of x changes from what? Positive to negative. So when does that happen? At -2. Now, that's the only thing we could say last chapter. However, we know the first fundamental theorem. So I can actually find G of -2. Well, we already found it. What is G of -2? 1. So it's at the point -2, 1. Because why? Let's justify it. Because f of x changes from positive to negative. All right, pretty good? All right, let's do another one. So for what values of x does G have an inflection point? Well, inflection points deal with what derivative? The second derivative. So G prime is equal to f prime. We already kind of talked about it. So I don't have an f prime graph. I have an f graph. So what are we really talking about? The slope of that graph. So when does the slope of that graph tell me I have a point of inflection? I get x equals -1 and x equals 0. And then let's justify it. Because why? The slope of f changes sign. Love it. All right, pretty good. All right, let's do some more. All right, I need a reader. Thank you so much, Harsha.
The function g is defined and differentiable on the closed interval -7 to 5 and satisfies g of 0 is equal to 5. The graph of g prime of x, the derivative of g, consists of a semicircle and 3 line segments as shown in the figure.
All right, so right here, g of 0 equals 5. Does anybody remember what that's called? Initial condition. That is called an initial condition. So we already talked about this a little bit. We kind of solved for C, remember? And so we can't really solve for C necessarily because we don't actually know what the function is. All right, we just know G prime is equal to this. But this tells me kind of where I'm starting, okay? This kind of gives me a starting point. Remember we did just a moment ago, we started at like 1. Right, the integral from 1. Well, this integral is going to start from what? 0. It's going to start at 0. So when we build g of x, if I were to get to g of x, I have to take an antiderivative of g prime. True? All right, if I'm going backwards. So this is kind of the antiderivative. So I'm taking an antiderivative from 0 to x. Why am I starting at 0? Because why? This initial condition right here. And so I'm starting out from 0 to x of g prime. And a lot of the times I'll mess up here. I can't have my variables match, okay? So a lot of the times we use t. So it's g prime of t dt. So it's 0 to x of g prime of t. It's not allowed to be x. I will mess up. Please yell at me when I do, okay? All right, we can't have those variables match. But we have 0 equals 5. G of 0 equals 5. So that's why we have a 5 going on there. So we have 5 plus the integral from 0 to x of g prime. Here's another way to think about it. What's the integral from 0 to 0? 0. So if that goes away, we better get what? 5. You following me? So I want to do one more with you of just setting it up. If I just set it up, if I gave you an initial condition of g of 2 equals 7, let's just play around with this one. This isn't this problem, but let's just play with it. What would be g of x? How would I build this? 7 plus the integral from 2 to x of g prime of t dt. That's how I would set that up. Are you following me? All right, that's a very important step. We'll be using that a lot as our time goes on. All right, so let's look at part B. Let's use this expression to find g of 3. And so where am I starting on this integral? Starting at 0. And I need to go all the way to 3. So I need to find all of that area right there. Well, good thing we took geometry. What is the area of a circle?
Pi r squared.
Pi r squared. Pi r squared. So what is my radius here? 2. So what's my whole circle?
4 pi.
4 pi, right? And so I don't want all of it, though. I don't want all of it. How much do I want?
What, half of it?
I don't want half of it. I want a quarter of it. So how much is that part right there? That's just pi. All right? That's pi. And so I now have that being pi. So I have 5 plus pi plus, now I need to find the area of this triangle right here. And what's the area of that triangle right there? 3 halves. All right. So I have 5 plus pi plus 3 halves. And a lot of the times on a free response question, I leave it just like that. I really do. Now, some people don't like that. They'll make the 5, 10 halves, combine them, get 13 halves plus pi. All right. But a lot of times I leave it. All right. I don't care. There's the answer. All right. And you are allowed to do that. And here's why I suggest you kind of leave it like that. What happens if you add them together and get it wrong? Guess what happens? They take everything. Okay, they take all that answer. Even if you had the answer right and then you kept going and now you messed up your answer, guess what happened? It's wrong. Okay, they'll give you nothing for it. All right. So a lot of times, leave it. All right. Here we go. Let's keep going. So I have g of negative 2. So this is 5 plus the integral from 0 to negative 2 of g prime now. So which way are we moving? We're moving backwards. So that area used to be pi. Now I think of it as what? Negative pi. So g of negative 2 is equal to 5 and then what? Minus pi. All right, because I'm going backwards. Now, I know that this didn't ask for it, but if I kept going onto this triangle right there, if I go backwards, what's the area of that triangle? That would be what?
5 halves.
Okay, maybe. That'd be positive now, all right? Because it's under, it's going backwards, it'd now be positive, all right? All right, let's look at part C. So this says, find the x-coordinate of each point of inflection of g of x. Now, a point of inflection deals with what? Concavity change, true that, but what derivative? The second derivative. Now, can I actually get the second derivative here? No. But what do I have? I have the slope graph. I have the first derivative graph. So what do we want to think of for the second derivative? The slope of this graph. So when do I have a point of inflection? It will be 3 times. Nope, negative 2 is not a point of inflection. X equals 0, x equals 2, and x equals 3. Now, I know some people want to say x equals negative 2, but what makes a point of inflection? The slope of, not f, but g prime of x changes sign. All right. Negative 2 didn't change its sign. It said the slope would be positive to the slope being positive. All right. Now, could that be a jerk? Maybe. Maybe. But it is not a point of inflection. Okay? All right. Let's
The
keep.
jerk is like the third derivative?
This is a real AP problem. All right. What year was this one in? 2012. All right. Fantastic. All right. You'll see similarities as time goes on. And that's kind of what we're needing. All right. More than likely there'll be an F prime graph. Now this is actually going to be a G prime graph as I look here, but they're all the same. All right. All right. Gunner's going to read for us.
Let f be a continuous function defined on -4 to 3, whose graph consisting of 3 line segments and a semicircle centered at the origin is given above. Let g be a function given by g of x equals the integral from 1 to x f of t dt. Find the values of g of 2 and g of -2.
All right, let's do it. So here we go. So I need to find G of 2. Where's my starting spot? Starting at 1. I'm starting right here. And if I find G of 2, that's finding the integral from 1 to 2, right? So I need to find the area of that little triangle right there. All right. Well, how do we find area of a triangle? 1/2 base times height. Well, what's this height? That's the hard part. What's the height there? Not -1/3. If it goes one more, it goes to -1. So this portion right here would be -1/2. And so what's the area of that triangle down there? -1/4. All right, it's 1/2 times 1 times -1/2. And so that would end up being a -1/4. Now, why is it negative, guys? I'm moving to the what? The right, and it's below the x-axis. That's why it's negative. All right, let's look at the second part. So now if I do g of -2, that's finding the integral from 1 to -2. So which way are we moving now? We're moving backwards. I need to find this area, and I need to find this area. All right. Well, good thing I know my geometry. What's the area of a circle? Pi r squared. So how much of it do I want of it? I want half of it. So what is the area of that semicircle? Okay, what's the area of the entire circle? What's the radius? 1. So what's the entire circle? 1 pi, right? It'd be 1 pi. Pi r squared. All right. And so the area of the entire circle is pi, so then that would be pi over 2. Now, is that positive or negative? Positive, because it's below the x-axis and I'm moving backwards. You following me? All right. And so now we need to find the area of that triangle. So what is the area of that triangle? 3/2. All right. However, what do we want to think of that 3/2 as? Negative. We want to think of that as negative because it's above and I'm moving backwards. So what is my answer? Pi over 2 and then what? -3/2. All right. And that is my answer. I don't keep going. That's it right there. All right. All right. Let's look at part B. Guys, if we did those two things right, we'd get 1 point there and 1 point there. We're 2 out of 9 right now. Congratulations. You can win. All right, let's look at part B now. I need a reader. Thanks, Miller.
For each g prime of -3 and g double prime of -3, find value or state that it is.
All right, let's do it. So we need to get to g prime. So what is g prime of x? Just f of x. Exactly. All right. And while I'm at it, let's do g double prime. So g double prime of x is equal to f prime. All right. All right. So if I need to find g prime of -3, what am I finding here? Just f of -3. I'm just finding f of -3. It's that point right there. And so what is that point right there? 2. It's 2. If I did that right, I'd get another point. We're 3 points now. All right, let's do another one. So now we find g double prime of -3. Well, what does g double prime mean? It's the slope of f. Okay, it is the f prime of negative 3. So now I need to find the slope right there. And what is the slope right there? 1. Congratulations, you got another point. All right, if you get 4 out of 9 on every single free response question, you'll pass the AP exam. You will.
Really?
True that. Becca's going to read for us.
Find the x-coordinate of each point at which the graph of G has a horizontal tangent.
All right, let's stop there. What does it mean for G to have a horizontal tangent? Not f prime in this case, but what?
Oh, just F. No. F is equal to 0. Yeah.
G. All right, so G prime is equal to 0, which really we're talking about what? F would be equal to 0. All right. Actually, if this year, if you stated that G prime equals 0 right there, you get a point. All right, you get a point for that. All right, keep going.
For each of these points, determine whether G has a relative minimum, relative maximum, or neither minimum nor maximum at the point.
All right, fantastic. So when does G prime equal 0? Let's answer that question. When does G prime equal 0? At x equals negative 1 and x equals 1. If you did that, you get another point. All right, so we're up to 6 already out of 9. Now, let's talk about at x equals negative 1. So at x equals negative 1, what's happening here? Do I have a relative min, max, or neither? I have a relative what? Max. Why? F of x changes from positive to negative. Love it. All right. And then what's happening at x equals 1? We have a relative. We have neither. Why do we have neither? Because why? Don't say it ever. F of x never changes sign. All right. So if we justified both of those correctly, we got our 7th point. Now, are any of those 7 points actually hard to get? Like literally, have we done something really, really difficult? No. All right. All those are doable. All right. Let's look at part D now. I need another reader. Thank you so much, Hubin.
For negative 4 is less than x, is less than, and x is less than 3 final values of x for which the graph of G has a point of inflection. Explain your reasoning.
All right. How do we get to a point of inflection? When what of f prime? When f prime changes, right? So it'd be the slope of f. All right. So where are my point of inflections? X equals negative 2 and x equals 0 and x equals 1. Because the slope of f changes sign. The slope of f, not f prime, silly. The slope of f changes sign. All right. So if you listed out those 3, you got a point. Your justification was also a point that year. All right. Pretty good. All right. All right. I would like you to complete the other 3 free response questions. All right. You also have answers posted on your Canvas, or they're actually on the AP College Board website. I'd like you to check your answers too. Now, do I want you to check the answers right away? No, I want you to try them first, okay? I think you'll learn from that way. All right? So those